Hello everyone, I hope you are doing well. So in today's video, we are going to go through the 2021 Specialist Maths Exam 1 for the Northern Hemisphere. And just like always guys, if you guys want private tutoring in Specialist Methods, Physics or Chemistry, you can always email me through this email. I hope this video finds you well and helps with your specialist studies. Let's smash through this video. Question 1. Consider the function f with the rule of f of x. Find all values of x for which the second derivative is equal to 0. Alright, not hard. So let's derive it. Let's find its double derivative. So let's find the first derivative. That's basically going to be, bring the 2 in front. So it'll be basically just x. And derive sign is cosine x. And derive it again. So this is our double derivative, which is 1. And negative sine x. Beautiful. So this is our double derivative. And it says find the values of x for which the double derivative is equal to 0. So we want it to be equal to 0, meaning that this over here equals 0. So basically it's just we're solving for sine x equals 1. Bring that 1 to the other side. Easy. This is going to be a general formula, like a general rule. So general solution. So what we're going to need is, what I would do here is I'll draw a normal sine function. So I'm going to draw this normal sine function. Let's draw a normal sine function. All right. Draw just a nice sine function. Look there. Not the most, does the job. Yep. So let's just draw a normal sine function, like a reoccurring sine function like this. And let's have a look at the pattern that gives me the solution where, so here it's a normal sine. So look, we've drawn this blue part, which is the sine, and I'm going to draw, an orange part, which is the y equals 1, which of course is, because this has an amplitude of 1, it always intersects over here, which look, 1. Okay, but what is the general formula? What is the general rule? Because remember, this is going to be a general solution because we're not giving a domain. So just looking at this, if I know that, this here is 0, and then this here is 2 pi, and then, this is 4 pi, and then it's always an addition of pi on 2. Can you see? You're always adding a pi on 2 to get this solution. Like, for example, so what is the period? So x equals 2 pi n. So this will result me in always occurring in the beginning. So here, here, here. But then we just have to add pi on 2 into it. Because if I add pi on 2, so imagine I'm here, I add pi on 2, get the first solution. And then let's try another one, which is like n equals 1. So it's going to be 2 pi. We start over here, we add pi on 2, we get another solution. And just this reoccurring. So this is our general, rule. So I'm just going to a little bit simplify it. So, oops, that's my basically answer actually. So those are the values. So we can say, of course, don't forget where n is an element of all integers. So let's write it nicely. So x is equal to 4 pi n plus pi on 2, and of course take a common factor. So x equals pi 4n plus 1 all over 2, where n is an element of all integers. That is it. Really, really nice question to start the exam. All right, perfect. Done. Next question. Explain whether the graph of f has any points of inflection. Now, be careful. So for us to have a point of inflection, this is what must happen. So let's just draw a normal point of inflection. Like, how does a point of inflection, let's say, let's draw like a x to the power 3 line, like x to the power 3. It's a stationary point of inflection, but it's the same as, point of inflection. So looks like that. Let's draw this. You see how that's a point of inflection. What makes it a point of inflection? Well, it's the change in concavity. Let's explain. Let's consider this as f. This function as f. This this yellow line. So we know that at x equals 0, what is it? The double derivative. So at the double derivative of f dash of x at x equals 0 equals 0, because that's where the point of inflection occurs. Remember, the point of inflection is where the double derivative equals 0. But that doesn't just, even if you have a double derivative equal to 0, it doesn't mean that it's a point of inflection, because it needs to meet another 2 requirements. Look at this. What do we mean by a change? It has to have a change of concavity. Like, can you see this one over here? Like, this is where, x, where the point of inflection. Let's look above the point of inflection, so around the positive x values. Can you see how the concavity is upwards? So can you see how the concavity is upwards here? And whereas if you go, in the negative, like below x x equals 0, we get, concavity that goes down. Can you see that there's a change in concavity? This is what is required for us to have a point of inflection. So can you see how at f dash, so the double derivative is equal to 0 when x equals 0, and of course the double derivative will become, let's say, so when x is greater than 0, so in the positive, so these parts here, can you see how it's positive because it's going upwards, it's concave up, so it's going to be greater than 0, and the double derivative is less than 0, so negative when we go x is less than 0. Can you see these are the three requirements that we must have for us to have an actual point of inflection? Let's check it if this graph over here, the one, does this overall have any point of inflection? So what I would do is I'm going to try to draw the double derivative, because you know how we know the double derivative formula? So let me draw, let's draw the f dash dash and x here. Let's draw that, which is basically, what is it? So it's 1 minus sine x, which is basically just, if I draw just a normal, let me draw it nicely. So if I just draw this over here, like a line, and let's say this is 2 and there's 0. So, and it's negative, so it's going to start off like this, basically. Okay, not like that. Okay, and then like that. There it is. So this is what we want. There it is. This is our graph. Okay, so I'm going to draw up this part out. So here is our graph, yeah? But of course, this is 1. Okay, now, if I was to ask, is there a change in concavity? Now, like for example, let's look at where the values are, like where does f dash of x equal 0? Well, of course, it equals 0 here. Can you see how f dash of, so it equals 0 here. And yeah, okay, we have those. Is there f dash of x, like, does the f dash of x, like, so let's say this point that's below it. Can you see how it's positive? The double derivative is positive, yeah, because it's above. And even on the right side, it's still positive. There's no change in concavity, meaning that for us to have a change in concavity, it has to be like this. It has to pass. Like if it was this over here, if it went down like that or something like this, then there is a change in concavity, because we have also negative, the double derivative becomes negative. So there's a change in that concavity. So overall, I hope that makes sense. So basically what we're saying is, there are positions where, the double derivative equals 0, but that doesn't mean there's a change in concavity, because there needs to be a change. Because as we see, there is no change. Like you can see that you can basically see that the whole graph is greater or equal to 0. It doesn't have where the double derivative is less than 0, negative. So it absolutely doesn't work. And yeah, we need to kind of state that statement. I hope that makes sense, yeah. As f dash of x is greater than 0, there is no change in concavity. There is no change in concavity. Hence, move this up. Hence, no point of inflection. Hence, no point of inflection. There is. So for a point, again, just overall, you need to meet these conditions where we look above it and below it, like the x values that are above the, where the double derivative equals 0, and below it, there should be a change in the signs, basically. A change in sign. Is it positive, negative? Yeah. This one has no. Perfect. That is it. And question 2, I've skipped it. It's mechanics, not anymore in the study design, so you don't have to worry about that. Question 3, let's try doing this. Let x be a binomially distributed random variable with n equals 4, p equals half. Let y be a binomially distributed random variable with n equals 6, p equals half. X and y are independent random variables. Let z be the random variable defined by this. Find the mean of z. Easy. So if we want to find the mean of z, we're going to have to find the mean of, because z is equal to that, so we're trying to find the mean of 2x plus 3y. Which, remember you could take those constants out, so it'll be 2ex plus 3ey. Okay, so let's find the expected value of x first. So, yeah, expected value, because we're dealing with binomial, you remember it's just n times p. So, this is x, so 4 times a half is just 2. And the expected value of y Is it, again, it's n times p, so half times 6, which is 3. There it is. So putting them in this formula, we should get 2 plus 3, 4, 9 equals 13. Done. That is your answer. Next question, find the standard deviation of z. So we need to first find the variance. So the variance of z, which is finding the variance of 2x. So 2x plus 3y. Okay. Now the thing about variance is to take the constant out, we need to square it. So it'll be 4 var of x plus 9 var of y. There it is. Now what's our variance? Well, let's look at this. So the variance of x is what? Remember, just the variance is, you need to find, first let's find the variance. Like the variance for binomial distributor, remember it's np 1 minus p. So in this example for x, it's 4 times a half, which is 2, and then it's 1 minus a half, which is just a half, so half times 2 is 1. So basically that's 1 for this one. So for var of y, so same thing, so coming back up. So it's going to be n times p, which is 6 times a half, which is, of course, 3. And then 1 minus your p-value, which is a half. So, yep, so it'll be 3 on 2. Done. Okay, so subbing them into the formula, we get 4 var of x is 1 plus 9, 3 on 2 equals 4, 27 on 2, which is basically 8 over, like 8 plus 27 over 2, which is 30, so 35 over 2. And so that's the variance. Okay, so we've got the variance of z. But remember, we're finding the standard deviation, so we need to take the square root. So your standard deviation of z is the square root of that 35 over 2. Done. Nice. Next questions. Okay, question 4. Let's have a try at this. Let's use green. Consider the function from -1 to 1 where f of x is just arc cos negative pi on 2 ek. Sketch the graph of f on the axis, labeling the endpoints with the coordinates. Really easy. So we know just first drawing. So if you remember, drawing just arc cos is just cos inverse. So what does the cos inverse look graph like? What does it really look? Well, it starts off, at 1. So the coordinate 1. It passes through pi on 2, like this. So, and the other endpoint is -1 pi. So imagine pi, which is, let's say this is -3, it's around here. So around here. So it would pass through pi on 2, which pi on 2 is like basically close to 1.5, let's say. Just something that look like this. But this is the graph of just cos. It goes like that, and then like that. This is what a cosine looks. But then what we're doing is, remember, so these are going to be, of course, that's 1, 0. This is, going to be 0 pi on 2. This is -1 and pi. And so remember, if you're going to minus pi on 2, you're translating a pi on 2 units down. So basically, you're taking this whole graph and you're translating it right there. So what's going to happen to it? So let's change some stuff. So this will be basically, this will be 0, 0. There's a lot of changes here. Let me draw it nicely. So that'll be 0, 0. This will be negative pi on 2. This one over here is kind of wrong. It's supposed to be between -1 to 1. So look, I've drawn it a little bit larger. So it has to be around pi on 2. So around there. So it goes like this. Like this. There it is. Not the most nicest to be drawn, to be honest. But yeah, that's the job. So that's going to be -1 pi on 2. Have I made any mistakes? Looks good. Have I labeled the endpoints? Yep, just two endpoints. Let me rub these out. We just need the endpoints anyway. Done. Sketch the graph of the absolute value of f of x. Easy. So what happens if you're taking the whole absolute value of the whole function? Let me just duplicate it, bring it down here. If you're taking the absolute value of the full function, the negative y values, so all these negative y values, so basically from here to here, you see that there's that negative y values, it gets reflected in the x-axis. So what we're just going to do is we're going to take this here, and just reflect it. So it'll be basically here, and then it's going to go like this. Like that, nicely. Let me rub that out. Oopsie, I'm always... There it is. So that's going to be 1, and that's going to be pi on 2. Done. Easy. Next question, sketch a graph of y just taking the absolute value of x. Okay, easy. So this one over here, just, okay, what do we do? Well, let's take the original. Remember with patterns. So when you're taking the absolute value of the whole function, you reflect all the negative y values in the, in the x-axis. Whereas what happens if you taking just the absolute value of the x values? Well, guess what? You look at, what you want to do is, the positive x values are over here, these positive x values over here, they get reflected in the y-axis. So like, these, so think of it like this. All these, basically, in other words, all these negative y values, or basically positive x values, get just reflected in the y-axis. Whereas this one here, the negative y values get reflected in the x-axis, this one in the y values. So basically, this part would look like this. Just going to take, it'll look like this. There it is, something like that. And rub that out. And I can just, there it is. So that's going to be -1, negative pi on 2. Easy. Perfect. Not too bad. Really nice question. There is a lot of questions in these in textbooks, so it's not too bad. Okay. Question 5. Let's have a look at this. Solve the differential equation in this, given that y is 0 equals 1, show that equals that. Okay, so let's do it. So it's in terms of x and y, so we're going to have to use separation of variables. Let's write it nicely. dy dx is equal to 1 plus y squared times, what can you tell I'm separating them right now? 1 plus x squared. So I'm going to integrate, remember I have to reciprocate the y, like the y parts here. So it's going to be 1 plus y squared dy is equal integral 1 over 1 plus x squared dx. So when you integrate that, that's just going to be, of course, tan inverse of y. And when you integrate this, it's going to be tan inverse of x plus c. Now we got an initial condition that we can substitute c. So when y equals 1, x equals 0, basically. So this is going to be 1. So arctan of inverse of 0 is just 0. So c in tan inverse of 1 is just pi on 2. So what am I doing? Pi on 4. Sorry, my brain just left there. Okay, and so we're rewriting it with the c value now. Okay, plus pi on 4. Now, we're solving for y, yeah? So we're going to tan inverse on both sides to get rid of that y. To make y the subject, basically. To get rid of that tan inverse. So it becomes y equals tan of this whole expression over here. Tan over -1x plus pi on 4. Now, don't just give up here because this is what we're trying to show. Well, it's actually not bad because what you might think is, okay, think of these. It's like tan and two things being added. Think of them like this. Let's make this here be A, and let's make this be B. So can we just write this as y equals tan A plus B? So what does this remind you? Remember that tan A plus B can be simplified using your, of course, your compound angle formulas. It simplifies to tan. So y equals, let me write it. So y equals tan A plus tan B all over. So 1 minus tan of A times tan of B. And, okay, so let's do it. So y equals, what's tan of A? So what's tan of this value over tan, like, tan inverse? Well, they're going to cancel out. So it's just the inside x. So it's just going to be x. What's tan of B? So you know how B is pi on 4. What's tan of pi on 4? It's 1. So positive 1. Again, 1 minus tan of A. Remember we said it was x. And tan of B was, tan of pi on 4, which is 1. So it's this value here. And this is how we've shown it. Done. Not really bad. Nice. Next question. Find y of 1 over root 3 in the form of this. Okay. So yeah, we just sub that in to our formula. So, okay. So y is equal to what? X plus 1, show that, x plus 1 all over 1 minus x. So if I subbing, 1 over root 3, I'm going to actually reciprocate it, because if I'm getting in this is going to be rationalized overall. I'm just going to rationalize it right now. So this becomes root 3 over 3, by the way, when it's rationalized. So I'm going to sub that in there. Root 3 over 3 plus 1 over 1 minus root 3 over 3. Then make it as a common denominator. So it'll be root 3 plus 3 over 3. And 3 minus root 3 over 3. Which becomes what? So, it's basically, these are just going to cancel out, basically. It's both heads. So basically it'll look like this. Yep, and so of course we're going to have to rationalize this more. So I'm going to multiply both sides. So like multiply, let me just write this as 3 minus root 3. Nice, like that. No, what was it? No. It was plus, yeah. So it'll be 3. What am I doing? Sorry, what? So yeah, 3 plus root 3, what? 3 plus root 3. Okay, so I'm going to rationalize it. So 3 plus root 3, multiply that. And then 3 plus root 3. Which gives me what? So basically 3 times 3 is 9. Then, 3 times that, and then do it again. It's going to be 6 root 3 plus 3 over 3 times 3 again is 9. Then because it's a, difference of perfect, so you just multiply these ones. Minus 3. Which gives me, all right, that's a lot of work. So y equals 12 plus 6 root 3 over 6, which is basically equal to 2 plus root 3. Done. That's your final answer. All right. Question 6. Let's do this. So find the values of a and b for which this, given that the tangent to the graph of the relation at 1 on 1 has this equation. Easy. Now, if you're kind of confused what's happening here, think of it like this. Just make up a function. Like sometimes they just be so bland with the wording, but think of it like this. Imagine you had like a parabola. Let's say this function was a parabola, like that. And this point 1 on 1 is on this parabola, and there's a tangent drawn to it. So look. So 1 on 1. And this tangent is drawn to it. And the tangent equation is this. Of course, get it in y equals mx plus c, because this is I don't like it when it's in this form, because when it's in, you can easily find the gradient and stuff. So just get it in a nice form. Basically, this is the same as 9 minus 4x over 5. So it becomes, basically this is the same, 9 minus 4. So let me write it like, break it apart. Minus 4 over 5x. So this is the equation of this line. Done. Done. So can you see how we've just drawn it? So yeah, we want to find these values of a and b. How? Well, we need to make two equations, because like two simultaneous equations, because it's in terms of a and b. Well, the most easiest first one that we can easily find out is that, the coordinate 1, 1, it's on the, this formula, this relation here. So we can sub that in already. Remember, this is just a made up, but just like, so we can break it apart. So we can sub in 1, 1 here. So like 1 to the power 3, and the y coordinate is also 1, plus a 1 to 1 squared is just 1, equals b. So 1 to the power 3 is 1. 1 times 1 is 1. So plus a equals b. So hence b minus a equals 1. That's, yep, is that right? So if I minus a on both sides. Yeah, that's your first equation. Done. So we need to find the other equation. So the other equation is really easy because, well, like, what's the gradient of this? So what's the gradient of this straight line? Well, we know it straight away, it's negative 4 over 5. The gradient is just negative 4 over 5. So why don't I implicitly differentiate this and find the gradient and sub that in there? So like, okay, so let's differentiate this. Of course, the first part is here you have to use the product rule. So when u is equal to x to the power 3, v is equal to y, and the u dash is, of course, 3x squared. V dash is dy dx, because when you derive y, it's 1, but remember, you derived it in terms of y, which you have to write dy dx. And so, use the product rule. So multiply that by that. So it's going to be x to the power 3 dy dx plus 3x squared y. Yep, so we've derived this, and then let's derive also this, which is, of course, 2ay, but because you derived it in terms of y, you have to write dy dx in front of it. And, b is a constant, so when you derive b, it's just going to be 0. Done. So this is the derivative formula. And basically, we've done most of the stuff, because now, guess what we can do? We can sub in this one-on-one. We have the x and y coordinates, and we know what the gradient is. It will give us negative 4/5, the gradient of a tangent. So we can sub those all in there. So 1 to the power, so if I sub in 1, 3, dy dx is, of course, negative 4/5, it's our gradient, plus 3, 1 squared, and, of course, y, 1 plus 2a, y is, of course, again, 1, dy dx is negative 4/5, equals 0. Again, these are all going to be 1, so you don't even have to worry about these. All right, so okay, let's simplify some stuff. I want to make sure if I haven't made a mistake here anyway. Yeah, it looks good. So, okay, negative 4/5 plus 3 minus 8a/5 equals 0. So what I'm going to do actually is I'm going to make these, kind of find the common denominator, which is just negative 4 plus, 15/5. Which is 11/5. This is 11/5. So that's 11/5 minus 8a/5 equals 0. So I'm going to bring that 8a/5 to the other side. 11/5 equals 8a/5. You can see how they have both denominator 5. We can cancel those out, so it'll just become 11 equals 8a. And divide both sides by 8, we get 11/8. So we got our a value done. Now what we can do is we need to find our b value, and that's easy because, we have this formula over here. B is just 1 plus a. So what's 1 plus 11/8? That equals b, which is basically 8 plus 11/8 equals b, which is b equals 19/8. Done. That is perfect. Those are your a and b values. Next question 7. Let's try this. So a particle moves in a straight line so that its acceleration is this, where its displacement from a fixed origin is x meters. If its velocity is 4 when x equals 0, find its velocity where v is greater than 0 in meters per second when x equals 2. Typical nice question. So we have the acceleration formula. So we can write acceleration is equal to 5 plus 6s. And we want to get it in terms of velocity, but in terms of x, because remember, we want to sub that too. Well, the most easiest, if you look at your, concepts, like the formula, acceleration formulas, you would see that acceleration is equal to this formula over here, d dx half v squared. This is what we want to use because we can solve for v, but it's also our expression is in terms of x, as you can see. So what we can do is we can replace this, acceleration with this whole expression over here. So d dx is half v squared is equal to 5 plus 6x. So how do I get rid of this d dx? Well, I have to integrate both sides. So if I integrate both sides, 5 plus 6, I have to integrate this side. So what's that going to be? So it'll be, 5x plus 3x squared plus c. Yes, perfect. Now, we want to find this c constant, which is quite easy because we know that when x equals 0, the velocity is 4. So we can sub that in. So 1 over 4 squared, which is 16, is equal, if you sub in 0 to the x, it's just going to be c. So your c value is 8. So let's sub that in back here. 5x plus 3x squared plus 8. Multiply both sides by 2 to get rid of that half. So basically, if I multiply everything by 2, it'll be 10x plus 6x squared plus 16. Then take the square root, so you get plus or negative square root of this whole expression over here. But because we know that velocity is greater than 0, we don't worry about the negative. So we just make the positive. Okay, there it is. So this is our formula. And guess what? We want to find the velocity when x equals 2. So let's sub in when basically v of 2 into this formula, which is 10, 2 plus 6. So 2 squared is 4 plus 16, which gives me 20 6, 12, 18, 24, 24 plus 16, which gives you basically, this becomes 40. So it basically becomes root 60, which is what? So which root 60 is how many 4s can get into it? So 5 times. So 15. Okay, so basically you can write this v of 2 is 2 root 15. And 15 can be simplified more further. That's your answer. Done. And yeah, meters per second. That's it. Really, really nice question. Wow. Yeah, 3 marks. Really good. Question 8. Let me just use a different color here. Find the volume of a solid revolution formed when the graph of this from x equals 0 to x equals 1 is rotated about the axis. Easy. So we're trying to find the volume. Remember, volume is what? It's pi integral. Where are we rotating? Because we're rotating about the x-axis, so we write dx. And where are we going from in terms of x values? We're going from 0 to 1 over 6. And remember, you have to find y squared inside, which is basically just squaring this whole expression here. So, 6 squared is 36. And squaring the bottom also will get rid of that square root. So it's 1 minus x squared. Here, we can actually we can use difference of perfect square to factorize it. So this becomes like, you can kind of factor this to be like, let me move this a little bit further apart. Like that. This become 1 minus 3x and 1 plus 3x. And what does this remind you of? Partial fractions. So let's do partial fractions here. So actually take that 36 out as a constant actually. Let's do that. That one there. Bring that over here. Bring that v over here. And 36 here. Okay, so we have this, and so we're going to find the part, like we're going to make sure we use partial fractions here. So let's write the whole expression down here. 1 minus 3x, 1 plus 3x is going to be equal to, of course, a 1 minus 3x plus b 1 plus 3x. So, of course, it's going to be 1 equals a 1 plus 3x plus b 1 minus 3x. We can actually sub in values straight away to get a and b. Like, for example, if I sub in when x equals 1/3, do you know what's going to happen? Well, let's put it into this x value. So if I put x equals 1/3, so it's going to be a 1, plus 3 times 1/3 is just 1, so it'll be 2. Because if I sub it into this one here, 1/3, it'll be what? So 1 minus 3 times 1/3, which is basically 1. 1 minus 1, 0. So we can actually get rid of this one, and it's going to be just in terms of a. So our a value is just half. Done. And I can do that also for the a to find, so to get rid of a, because all I have to sub in is x equals negative 1/3. So if I sub in x equals negative 1/3, this will cancel out also. So we can do that also. So if I sub in negative 1/3, this will cancel out, and let's see what happens here. So b equals 1 minus 3, negative 1/3, so it becomes basically positive. Basically positive 1. So basically it's also b equals 1/2. Done. So we got our a and b values, so we can write these as halves here. So we can write halves here. And so now, guess what? We can write this whole expression in terms of partial fractions. So let's do that right now. So in terms of partial fractions, it's going to be... Actually, take the half out. Like, you can take the half as a constant out. Let's take those out. So bring that over here. Put a 2 here. And it's basically... These are just going to become ones now. They're just going to be... So it'll be... The first one will be... 1 minus 3x plus 1 plus 3x. Perfect. So now they're so much easier to okay, what's 36 over 2? That's 18 basically. That's just simplified to 18. So v equals 18 pi. Let's integrate these now. So it's just 1 over derive the bottom part, which is negative 3. And of course, it's going to be a log. Absolute value of 1 minus 3x. Close up absolute value sign. Plus again for the other one, 1 over derive the bottom part, which is 3. And then find the log e absolute value 1 plus 3x. Close it from 0 to 16. Okay, so you can actually take the 1/3 out, like it's just a common factor. So take that 1/3 out. So this becomes a negative. It's negative, and this will we can get rid of this. Okay, now All right. There it is. Nicely, just let's nicely put this together. Okay. So what's going to happen is, of course, we got two logs. Like, just a little bit, make them nicer by pushing this one over here. Putting here and putting this one over here. What happens if you have two logs that are minusing? By the way, that becomes, so this becomes 6 pi. And becomes simplified. Okay, what happens when you have two logs minusing? Of course, what's going to happen is they're gonna divide. The inside's going to divide. So it becomes log e absolute value 1 plus 3x all over 1 minus 3x, close bracket, from 0 to 1, 6. Okay, now we can simplify, sub those values in. So, okay, so let's sub in 1, 6 first. So the top part will be 1 plus 3, 1, 6, which is 1 plus a half, which is 3 on 2. Top part's 3 on 2 all over. So doing the bottom part 1 minus 3, 1, 6 is basically 1 minus a half, which is a half. Okay, and so that's that first part, which is basically just, if you don't kind of realize already, you're going to get rid of this 2. It's just 3, basically. Yep, because 3 on 2 times 2 on 1. Yep, it's 3. Perfect. And then also minus, then you kind of redo everything, but you sub in 0. But look at this. If he's actually sub in 0, this will be 0, this will be 0. It's just 1 divided by 1, which is log e of 1 is 0. So there's no need for that. What am I doing? Oh my god. I forgot the log e of 3. Yeah. Done. Because, yeah, then, you know, minus if you sub in 0, it's going to be all 0. It's going to be log e of 1, which is 0. Perfect. So, yep, I subbed that 1, 6 in. Just inside became 3. And, yeah, log e of 3. Done. Velocity is equal to... velocity, but, yeah, the volume is 6 pi log e of 3 units cubed. Okay, how many marks is this, to be honest, man? That's a... yeah, 4 marks. Okay, question 9. Let's smash this one. So, question 9, show that the derivative of secant x is equal to that. Well, in the new study design, it's actually in your formula sheet, but because, like, this is the old study design, they didn't give it in your formula sheet, so you had to do it by hand. It's really easy. So, okay, we know that secant is what? It's 1 over cos x, yeah? Well, if you're deriving 1 over cos x, you're just using the quotient rule because it's just two things being divided, yeah? So, if you're finding the d dx of this expression, we're using the quotient rule. Of course, where u is the top part, your v is the bottom part. And of course, u dash is 0, v dash is negative sine x. So the derivative of this expression, let's see here, this expression is equal to, remember, it's v times this u dash, which is just 0, minus, multiply these two together, negative sine x, so it'll become positive sine x, all over v squared, which is cos squared x. Okay, let me write this out. Okay, now we can write, you know, sine x, you know, divided by cos squared is just sine x over cosine x times 1 over cos x, because, you know, the bottoms are going to multiply, that's cos squared x. Yep, and the top part also sine x, which is what? What's sine over cos? It's tan of x. And it's what's 1 over cos? It's secant x. You see how we've shown that it's equal to that. Done. That's how you get it. Hence, so using those, show that the derivative of this is equal to that. Easy. So remember, what are the rules for deriving logs? They're really easy because when you have a log and a function inside, so when you're deriving, let me write that down. The derivative, so when you're deriving a log inside and it has a function, like this is when you're deriving logs are so easy to derive because it's just equal to f dash of x, the inside derived, over f of x, the original function. So using this rule, that's how you derive logs. What I'm going to need to do here is do this. Put it to the division sign. Okay, so I'm going to first derive the inside. That's the f dash of x part. So what's the derivative of secant x? Well, we just found out the derivative of secant x is secant x tan x. So let's write that down. Secant x tan x plus, and then of course you need to derive tan, which is secant squared x. Okay, and then what you're going to need to do is you're going to derive it by the original. Done. Beautiful. Now, There it is. So we're trying to show that it's equal to secant x, so we're going to just break it apart. So let's break it. Well, secant, you know how secant is just 1 over cos? Let's write that down. 1 over cosine x. Cosine x. Times tan x is just sine x over cos x. Yeah, I'm just breaking it all apart. Plus, and then you have, but before we do that, just multiply these two. So these are going to be basically, it's going to be sine x. So the top part is going to be sine x. You can write this as just, so sine x. And what's cos x times cos x? Because it's equal to cos squared x. So we're just simplifying this. And secant, x is what? It's 1 over cos squared x. Can you see how the denominators are equal? So you can actually just add these up. It's going to be nice. So it's 1 plus 1 over basically that. Look how easy that became. So we've simplified that part. Now, we're also going to simplify the bottom two. So secant is just 1 over cos. And tan is sine x over cos x. And remember, the denominators are the same. So we can add the numerators. So it's going to be, again, sine x plus 1 over cos x. Okay, so we got this here. This fraction divided by that fraction. And that's easy. You remember what's going to happen when you derive a fraction. So let's write the top part first. Just so we can show the cancelling out. We have a cosine squared x. Times, you remember, when you're dividing it, what I'm going to do is I have to reciprocate that. So I can make it a times. Cosine x over sine x plus 1. All right. And you can see there's cancellation. These cancel out with that one. And this cos x cancel with one of these cos x. So we actually left that with 1 over cos x, which is, of course, secant x. We have shown that it's equal to that. Beautiful. Okay. Find the length of the curve of this for the interval negative pi on 3 to pi on 3. Easy. To find the length, so we know that length is what? So to find any length, so the length is you remember, it's integral where are you going? So negative pi on 3 to pi on 3 of the square root, square root of 1 plus dy dx squared dx. This is your formula. So, all right. So let's find dy dx first. Dy dx of this expression. Remember, it's a log, so the same kind of formula again. So you derive the top part, which is secant. What was secant again? Is secant so secant times tan x. So let's write that down. Secant x tan x divided by what's inside. So secant x. And you can see that these two secants here cancel out. So we get tan of x. So that's your derivative. And of course, you're squaring that. You're squaring it. So square that. So it'll be tan squared x. Tan squared x. So we can put that in here. Tan squared x. And if you don't know straight away, 1 plus tan squared x is, remember, it's one of your identities. 1 plus tan squared x, it's in your formula sheet, is equal to secant squared x. So we can kind of replace this with secant squared. And what happens if you have these are going to cancel out, the square root and the, squared. Done. So we're basically just integrating this expression over here now, which is easy because the integral of secant x this is using integration by recognition because they gave you a hint here. Going back here, like if I want to derive secant x here, if I put an integral here, I want to derive this. I have to derive this whole expression. And can you see how with the integral and the derivative are going to cancel out? The antiderivative of secant x is this basically. That's the hint. So let's write that down. So we already know how to antiderive this. So it'll be, this secant antiderived is going to be log e or secant x plus tan x. Okay, from negative pi on 3 to pi on 3. All right. Let's start subbing values in. Be log e. Secant is, by the way, 1 over cos, so subbing pi on 3. So what's cos pi on 3? That's half, so it'll be 2, basically. This will be 2. Plus, if you sub in pi on 3 on tan, it's root 3. Close that. Minus, now do it subbing the other terminal in. So it's going to be 1 over cos negative pi on 3, but it's the same as cos pi on 3. And cos pi on 3 is a half, so it'll be 2 again. But when you sub in negative pi on 3 on tan, it's going to be negative, so it'll be negative tan pi on 3, which is negative root 3. There it is. 2 logs minusing, what happens? Of course, they divide. Let's get those right there. There it is. And we can actually rationalize it, so let's also rationalize it. So let me just write it here, rationalize that. 2 minus root 3, just 2 plus root 3, 2 plus root 3. So it'll be 4 plus 4 root 3 plus 3 all over 4 minus 3. This becomes a 1, so it's just this, which is 7 plus 4 root 3. Done. We can rewrite this whole expression. 7 plus 4 root 3. Done. That's your length unit. I hope that's right. If I have not made any mistake here. Done. Question 10. Last question. Let's smash through this. Okay. So if find A where, root A is an element of all reals, given that this is that. Okay, so we can see that there's a lot of square roots. I'm going to square both sides, just get rid of that square roots. So I'm going to square both sides. So it'll be 1 over plus root AI plus 1 minus root AI all squared. And, if you're squaring this is just 2A. Okay, so guys, I'm just going to use a formula just because there's a lot happening here. I don't want to, so remember A squared plus 2ab plus b squared. So a is this, and this is our b. So it's a squared, so the square root's going to cancel out. It's just 1 root ai plus 2a. A is that, of course, so square root 1 plus root ai times, again, square root 1 minus root ai plus b squared. So this is squaring that, which the square root cancels out. 1 minus root ai equals 2a. See what we can cancel out? We can cancel out this root ai, this part here, and add these ones together, so it becomes a 2 here. You can actually straight away divide both sides by 2, actually. Divide this by 2, this 2, and this 2, so you can get, that's a 1 there. Okay. We're making some progress. I'll put this here. I'm going to bring this -1 on this side. We can get rid of that. Okay. Now what I'm going to do is, to get rid of the square root, I'm going to square it again. So I have to square root both sides. So if I square root this whole thing, the square root is going to, disappear now. So it'll be 1 plus, root ai, 1 minus root ai is equal to a squared, a minus 1 squared. So squared both sides. So of course this is the difference of perfect squared. So it's 1 minus ai squared, which is so that's positive a. Is equal to, of course, expanding that, it's just a squared minus 2a plus 1. Those ones cancel out. Actually, minusing a on both sides to make this 0. So we get a squared minus 3a equals 0. So a, take a factor of a out. So a equals 0 and a equals 3. But be careful, let's check if you have to check if they actually work. Do they satisfy this equation? So for example, if I sub an a equals 0 into this, yeah? If I subbed it, there's a lot of mistakes here. You have to kind of sub it into, because there's one mistake that won't work. So if I sub an a equals 0, let's have a look. It'll be, square root, if I sub an a equals 0, so this becomes 0, it's 1, root 1, plus, again, this will be also root 1, and equals, so if I sub in a 2 times a, so this all becomes 0 here. Is 1 plus 1 equal to 0? No, it's not. So basically, a equals 0 has to be rejected because it doesn't satisfy this equation. It doesn't actually satisfy it. I think that was one of the mistakes that student made with this paper. So just be careful. Let's try also a equals 3. So if I sub an a equals 3 in there, it's basically saying the square root of 1 plus root 3i plus 1 minus root 3i equals root 6. Again, square both sides. So if you square... Oh, okay. Yeah, we have to square both sides. So if I square this... And this 6, square, it just cancels out. So again, the same formula I'm going to use here. So it's going to be 1 plus root 3i plus 2. Multiply these two together. So it's 1 plus root 3i dot 1 minus root 3i. Yep, plus square root. No, the square root is going to cancel. It's b squared, so it's going to be 1 minus root 3i equals 6. Okay, you can see that these already cancel out. This part here to this out. These ones are going to add together. And it's just the same as the other one. Look how nice. So divide both sides by 2. This becomes a 3. That becomes, you drop these out here, and that becomes a 1 here. Minus, 1 on both sides, you get 2 now. Okay. So, and then square both sides. So this will be a 4. Now you're basically, expanding this, which is basically 1 minus 3i squared is equal to 4, it is equal to 4, plus 3 equals 4, 4 equals 4. So this statement works. So this is your only solution. And done. That is it. I hope this video solutions helped you with your studies. Good luck with all, guys. And yeah, have a great day. Bye-bye.